think I know most folks at this point, but just as a reminder, I'm Katrina Manigan. I am the Director of Buildings and Homes for Denver's Office of Climate Action, Sustainability, and Resiliency. We'll run through our office first. Tom, do you want to say hi?
Sure. I'm Tom Gleason, Green Building Outreach Administrator on the CASR team, and I'm here to listen in and take notes.
Thanks, Tom. Sharon?
Hey everyone, I'm Sharon Jay. I'm managing the Energize Denver performance policy and make sure we line up with everything that we're doing.
Thanks, Sharon. Let's go to the CPD team. Chuck, you want to say hi?
Hello, everybody. Chuck Bartell, City and County of Denver, Mechanical Plumbing Plan Review Engineer Supervisor.
Perfect. And Robert?
Hi, Robert Pruitt, City and County of Denver Building Inspections Combination Inspector.
Thanks, Robert. And Alan?
Alan Yunong, Engineer Architect Supervisor for the Building Department.
Thanks, Alan. And stakeholders. Elizabeth.
Hey everybody, it's Elizabeth Gilmore with Energetics.
And Mark.
Hello, Mark Jelinski, Chief Mechanical Engineer at RMH Group.
Great. And Sean.
If I can find mute, there we go. Sean Dennison from New Buildings Institute. We have been serving as the technical advisor to the city.
Thanks, Sean. Okay, so I'm going to pass things back to Sean. In our last meeting, maybe just to center everybody's conversation today, I'll remind us sort of where we're at in the process because we all go bounce from meeting to meeting. So this group is one of 4 working groups that is meeting this month and in June to finalize proposals that will go back to our IECC code committee for a vote in July. And this working group was formed to look at the commercial prescriptive path and the minimum renewables proposals that NBI had drafted and worked on for the code committee's consideration. So we're looking to refine those 2 proposals. We've met once out of 4 meetings. This is the 2nd meeting. And in the first meeting, the group asked that we work to combine the 2 proposals into one prescriptive path, C406, to achieve sort of all those goals around electrification and renewables that the city has. And so I'll pass it to Sean to walk through that. We'll of course be wanting to sync the work of this group on the prescriptive path with the work of the modeling group around the performance path. And so maybe you can touch on that and how that will work, Sean, as you walk through sort of what this combined draft looks like. And Sean has annotated the draft, but we'll also really talk through how this draft we think captures what we heard from you all in the first meeting. But I'll note that there's things where we have further questions, and you'll see that as Sean walks through. So we're really looking forward to the discussion today to help us narrow and refine this further. And we'll see how far we can get. I'm hopeful this might be a group that doesn't actually have to meet 4 times, but you can tell us how close we are or are not today. So with that, go ahead, Sean.
All right. So we've done a few things in this combined proposal, and I'm going to highlight kind of the major topics first, and then we'll be able to look at each piece more carefully. So one of the things is that it just brings all of the additional options that are being proposed into one proposal, so you can see everything together, you can see the points together. I think that'd be easier. I think Courtney made a really good point. Probably no one who supports C406 is going to oppose greater flexibility, so there's maybe no point in considering them separately. And so we've tried to highlight which ones those are in yellow so that you can see where they've either been modified, we had to make modifications to the existing, or we've added additional options. The other thing is that it makes some modifications to the all-electric options. And these are to ensure that all electric buildings really are having a positive impact on operating costs. So previously, we'll discuss that in a moment. And then the other thing that it does is it provides a range of credits that are available for renewable energy. And this is because it is often not clear to people that the credits that are available for renewable energy, that is just the entrance point, and that the credits actually do scale up from there. And that is sometimes kind of just a mental barrier to understanding the full potential of renewable energy within the credit structure. So we've included that there are ranges, and we've also capped it. One of the things that we've heard is, you know, the need to incentivize electrification, and that don't want to just get there with renewable energy. So that's one of the things we want to make sure that we're hearing that properly from the working group as we have the discussion of this section. And then the last thing that is done here is some of the points targets for mixed fuel buildings have been calibrated and actually have been brought down. And in those cases, and this is another thing that we do want to discuss, and that was to ensure that a mixed fuel building could comply with the code without electrification and without renewable energy. They might have to do all the efficiency, but they could still get there. And so we kind of went through that exercise. And those are kind of the big picture things. I did go in a little bit more depth on a couple of them. So I think that it would probably be best to start with the electrification, even though that's at the bottom of the table. And because this is, I think, where we see perhaps some of the biggest changes. To qualify for the all-electric, for the electrification, partial electrification credits, and for a building that's going through, that's all electric, that wants to qualify for just that 10 credit points, they're going to be all electric, they have to have good electric space and water heating. So we start with C406.12, which is electric space heating, and this incorporates what is essentially the cold climate heat pump specification from the Northeast Energy Partnership. They have developed a specification and maintain a product list of cold climate heat pumps. These are heat pumps that continue to operate in heat pump mode to lower temperatures than your standard heat pumps. When we think about the climate in Denver, and we think about both carbon and operating costs for that matter, these are the sorts of heat pumps that we really want to see in Denver. The difference here between this and say just a straight up high performance heat pump requirement is that sometimes a heat pump with a higher HSPF, which is the efficiency rating for heat pumps, still doesn't operate as well at lower temperatures. So the NEEP specification introduces this, I'll highlight it here, these two, no, not this one here, of a COP at a specific outdoor temperature. So this maintains that at these lower outdoor temperatures, you still have this good COP. And sometimes that does come at cost for the HSPF at higher temperatures, and that's why it's specified separately. You'll note that the NEEP standard does have different HSPFs for non-ducted and ducted systems. And the NEEP cold climate now does have a standard for packaged terminal heat pumps. The issue with availability is still an issue. That doesn't change. But now that this is an optional path, as opposed to, this is not, we're not thinking of this mandatorily, there is an option to get through with a packaged terminal equipment. There just aren't a lot of equipment options right now. And then the last thing that we see here is it's not all about heat pumps. If you have a super insulated building, like we've talked about in the electrification section before, you can go through that way as well. 1.35 watts per square foot is the heating demand threshold for Passive House US, FIAS. And then this also just allows a certain amount of, as we've talked before, boost or spot heating, or if you might have, some minor areas that are, that you're just doing freeze protection or heating to a lower level. And we tried to reword this a little bit. We heard the comment about clarifying that this is an allowance for the whole building based on all of the conditioned floor area. So we'll talk about heat pump water heating, but in a moment. I think it'd be worthwhile to stop here and see if there are any comments about this partial electrification for space heating section. Mark.
Yeah, sorry, I was
Hi.
muted.
Yes, thank you. I guess the biggest comment I have on this is indeed the NEEP, spec, of course, but the NEEP spec only goes to 6 tons, and it's intended for small residential, essentially very light commercial equipment.
Mhm.
So this equipment is not typically available to serve the entire commercial market.
Right. And I think that that's an important piece of this conversation through, Katrina, I don't remember if it was this one or one of our other working group discussions. It's easy to lose track. But there was the discussion that larger buildings and buildings with central systems are more likely to model. And since this is a prescriptive approach, that it is more likely to be used on smaller, simpler systems. With that in mind, that might in fact drive some more buildings toward modeling. If they weren't going to model before, and maybe that's still a better option than going through the mixed fuel path. Does that cause serious issues for this equipment? I mean, for this option? Mark?
Yeah, Mark.
Yeah, I would say yes in the application of this. If it's now, I also recognize, and I'm completely in favor of all these options within C406. This is not the only way to do it. 100% on board with that. So acknowledge that. But I'm just going to say that this particular credit will be, I've never designed a building that would be able to accept this credit, not just because this heat pumps, but because I've never designed a building that was designed with all 6 ton and less individual pieces of equipment.
I'll chime in on the PTAC, or package terminal heat pump side as well. There's one manufacturer on that list. So I don't know that we can write a credit that's written around a single manufacturer. I just don't think the industry is ready for that.
Elizabeth, how often are you following the prescriptive path though? Because remember, this is one way. And
Every single time we use PTAX, we have to go prescriptive unless we're doing, something. Okay. But I cannot meet the performance path with PTAX.
Okay. Can we scroll up, Sean, and just take a look at because the first question we have for you all, yes, we should get into the weeds on exactly how the partial electrification is written, but I would first like to get some input on the overall structure, and then yes, we can refine exactly what would get partial electrification credit. And so I'd love to hear some feedback from the group first on the concept of there being one set of credit requirements for all electric properties, another set of credit requirements for all other buildings. And
I think we have to, I disagree, Katrina. I think you have to define what's all electric, because that's going to completely change. We basically are saying, PTAC projects are you just can't get there because there's just too many things that can't happen. A PTAC project's never going to get 52 points because they can't get heating, they can't get cooling, they can't get electrification. I think that definition is really important.
Okay, that's helpful to hear. But I think within that, I'm hearing that conceptually, like the direction of combining this to one set of points, we just need to get the definitions right. Of course, like I understand the definitions are important, but like, are we going towards the right concept?
In which way? Sorry.
By having one proposal that has renewables and electrification and efficiency all in it in one prescriptive proposal versus we had 2 in the last meeting. But here at least we're working off with one table. We've combined in all the ways to earn points so that it's all the modifications to C406. It's all just one proposal.
Yeah, I think conceptually, I do think we're on the right track. I think the idea of NEEP stuff is great, but as Mark pointed out, there's very, very few buildings that would fit into that. So maybe that's something you add as a credit. That project that does pursue that one really expensive PTAC, does that qualify for points? Or if you can get a certain percentage of your heat pumps to be with the NEEP qualification, it's not a standard that we can ask buildings to design to, but can we incentivize it? Yeah, I think that'd be great. Add some more options there for, like for example, if we've got all electric space heating, awesome. How about giving some extra points for all electric space heating that meets the NEEP thing? Start to introduce that concept, but I don't think we're ready to mandate that. There's just not enough equipment options.
Okay. That's helpful. We can go back to those all electric details. I think the other thing that I just wanted to check first conceptually is that, do you agree that the way it's structured right now, a building can reach the credit requirements without doing any electrification or renewables? They would have to do almost all of the efficiency measures, but we wrestled with exactly kind of how to combine what were separate proposals, right, with renewables and electrification and efficiency, in addition to the points. And so we think we heard from the group that you'd like buildings to be able to get there without having to electrify or do renewables this time for points, but that it's hard and they'd have to do almost all the efficiency measures. That's possible with the way the points are structured. Is that conceptually right?
It seems right to me. I'd probably want to play around with it and see how things fit, how different projects fit, and make sure we're not, causing something unintentional there.
Before we move away from PTACs, I did have the question. So since heating can be provided in a couple of different ways with PTACs, how is heating generally being provided in Denver projects that utilize PTACs? Is it the electric resistance option, or is it the central?
No, it's still a heat pump. The package terminal heat pump. There's one manufacturer on the NEEP list in the package terminal heat pump products. There's lots of package terminal heat pumps out there, but the heat pump element stops at 40 degrees. So we're talking about, let's be honest, this is affordable housing that we're talking about that primarily use PTAC. So that it would be really, really rough to reduce or eliminate that system as a potential.
I want to circle back to that, but I know Chuck had his hand up. So Chuck, can we go to you for some comments? And we can go back to Mark.
My comment was going to move away from the PTAC, so I'd say let's finish that discussion on PTACs. But yeah, I think that's if we really limit the use of those, it is affordable housing, and many new buildings typically don't use the prescriptive path, but like core and shell buildings will use the prescriptive path option often, and remodels or change of use or some of the simpler projects do typically utilize the prescriptive path. So if in an affordable housing space, there was like a maintenance area they're going to convert into a dwelling unit, they would use the prescriptive path for compliance.
Okay.
So,
that's helpful. Can I ask, and then I'll go to you, Mark, but since you want to, let's stay on PTACs. And I want to understand better what you're saying, Elizabeth, and see if what you're seeing come through too, Chuck, and then we'll go to you, Mark. I think, Elizabeth, you're saying that most of what you're putting in today is PTAC heat pumps or PCHPs, just they're not the cold climate ones, because that wasn't what I thought I'd heard you say in the past. PTACs can often be paired with a hydronic or boiler system for some of the heating. What are you most commonly putting in, and what are you most commonly seeing come through, Chuck?
well, would You asked Elizabeth a question and then you came to me. So
Oh yeah, sorry, each of you. I'd love to hear from each of you on the question of what's going in today.
It's the plug and play package terminal heat pumps where, you know, you stick it in the hole, you take it out of the hole. They're really easy to maintain. It has a heat pump element. It's a packaged thing. And there's, I mean, there's only a couple of manufacturers of heat pumps that can, where the heat pump element will function below 40 degrees. I know of one that'll go down to 30, but that's it.
Understood.
And then,
Yeah.
you know, this ice air manufacturer, it's not a plug and play. So it's a thing you have to drywall around, and it's very high end. It's very expensive. It's not an option for affordable housing. They just wouldn't go with that.
Chuck, do you want to answer that same question? What is coming through for?
no, I would agree that a majority is plug and play electric resistance. I mean, some of the older buildings with retro that we've seen come through retrofit do have hydronic associated with it, but for the most part, it's just packaged plug and play.
You're not seeing much hydronic come through right now, is what you're saying, Chuck. Most of them are just either electric resistance or heat pump.
Yep.
Okay.
Yeah, and we don't see any electric resistance anymore. And I can, you know,
Yeah.
I think maybe I've seen hydronic like once or twice, and that's up in the mountains. But I don't think I've ever used hydronic PTACs in Denver.
Yeah, it's a couple of interesting retrofit of the buildings. And my question was using the NEEP standard. Are we requiring equipment to just meet the NEEP standard or actually be listed by NEEP? Because I know NEEP's kind of its own thing, and they charge quite a bit of money for each piece of equipment to be listed by them or on their list, but they're not really even a testing agency that tests the equipment. They just kind of verify that information. So I'd be very cautious if we're actually requiring it to be NEEP listed.
So before we answer that question, which is an important one, I do want to make sure that we're absolutely clear. So PTACs that just use electric resistance aren't really being installed in Denver. It is package terminal heat pumps that have electric resistance backup. It just happens to go a lot of the time because the heat pump only goes down to 40 or maybe 30. So
Okay.
we're really not seeing PTACs. We're seeing package terminal heat pumps in Denver.
Right. People
That
just use
helps
it
a lot.
interchangeably.
Got it.
Okay, and then to answer Chuck's question, it's structured right now to meet the specifications in NEEP's specification. And what you brought up is one of the reasons, because, you know, is that relying on this external organization that might have varying levels of speed of actually adding stuff and certifying things. I think that it's a little bit problematic. It's not terrible. You know, NIA's water heater spec is used all the time, and there's the same issue with that one. But the main thing is just the spec's actually pretty simple. And so it seems easier just to include the specifications in the code, and that'll just be easier for users. We did ask the question, does it make sense to just refer to the spec? Would that be better? It kind of sounds like you think it wouldn't be.
Okay. Mark, Chuck, does that answer your question just in terms of?
No, yeah, that does.
Okay.
I was just making sure we weren't requiring equipment to be listed by NEEP because because NEEP does have, like Mark and Elizabeth referenced, they have lists of approved products, but to do that, you got to pay the money to do it. And I know I can't remember where I read it, and it's been months, but there was one manufacturer that sort of that doesn't want to pay the money to get on that list because they didn't see the value to it. And so as Denver, I would be hesitant to force people to get on that list.
Great. Mark, you've been very patient with your hand up.
Yeah. Okay. Yeah. Quick comment on NEEP, and that is, yeah, don't use the actual listing. Another concern is they actually don't really even verify. They just charge to have people, you know, give them their information, and then they'll repeat that information. What that leaves, though, is the fact that there's not really a third-party verification of this. You would simply be going with the manufacturer's rating. And you know what? That's not an objection, because there's a lot of, in my world especially, a lot of the equipment that we work with is semi-custom, or we're working with manufacturers numbers. Okay, so that's NEEP. I think you've navigated that well by not saying shall be NEEP listed. However, the issue of the fact that the equipment just doesn't exist much beyond the NEEP listing is still to be considered. There was, let's see, overall, first of all, yes, you're going the right direction here on trying to put all this together in one place so that we can analyze it and do things such as, you know, I'm looking at the screen right now. You know what? I don't have to choose all electric space heating to get my 10 points if I've already qualified as an all electric building, which is an important point we got to get back to, Elizabeth brought up. But if I'm an all electric building, I only need 10 points. I can in R in particular, what we should be doing is further reducing air infiltration, right? There's 8 points right there. There's a couple others, infiltration in the envelope. That's how, first of all, that's what we should be doing. So you're even encouraging the right, path here by not making BTUs enter or leave the building in the first place. So.
Okay.
So, Mark, I have a question for you. So the systems that you're looking at that are larger than the 6 ton, but they're not central boiler based systems that would be fossil fuel. So can you give us some examples of what those designs look like?
Yeah.
Or what those types are? The
very large category is going to be in the simple even. I acknowledge that a good chunk of the projects I'm talking about, whether they need to be modeled now or will be modeled in the future, you know what? Modeling is going to be a much bigger aspect of that. And that's how we're going to have to prove out the less than simple projects. I get that. I accept that. But there's that middle ground of packaged rooftop units. That's one of the biggest categories. And in other forums, we've talked about the difficulty of providing heat pump based terminal heating when your base core system is a variable volume packaged system. You know what? There's a valid response to that about, hey, it's difficult to do these things. And the valid response is good. I kind of get it, but that's the answer to my question. Your question. The big middle ground there is packaged rooftop units, 10 to 40 tons, something like that, somewhere in that neighborhood. Probably should be modeling stuff much over that. Okay, I'll step up, but there's a middle ground that a lot of building owners and developers, I mean just not the developers in the bad sense of the term. I mean people who are developing buildings, right? They just need to be able to come up with something that meets their pro forma too. So,
and these are rooftop heat pumps, but they're just not rated this way. They're not rated down to these levels.
Heat pump that's a different question. I'm just saying packaged heating cooling systems that are not because now if you want to specifically talk about packaged rooftop units, right, they are not generally designed to go provide all the heating, and they're not, and we'll talk about this in the other forum, but they're not really capable of doing, say, even 20 degrees full heating without adversely oversizing them. So,
but there are these large package rooftop heat pumps, the 10 to 20 ton range, or I guess 6 really is what we have to concern with if there's nothing below 6 in the NEEP listing. But they are electric heat, so they could be eligible for all electric space heating, but they can't meet these cold climate specifications.
Okay, good. Yes, that is exactly true. You can buy an all electric heat pump packaged unit, but similar to the PTACs, they'll end up doing the majority of their heating with resistance because there's not a lot of heating that has to occur above 40 degrees. Mixed air temperature and et cetera. most of the hours of heating will be done by resistance because they just plain old shut off at 30, 40 degrees.
So based on the way that a lot of these projects are built, there is a certain amount of energy recovery ventilation requirements in the code currently. There are some holes in that. Would something like energy recovery ventilation as an alternate to cold climate heat pumps, would that provide a good balance of the way that the buildings are designed? And really, we're thinking about both
Yes.
operating costs and carbon impacts.
Yes. That goes to now, how would I design this? Yes, I would. That would be, first of all, reduce the envelope UA, and then further reduce the envelope UA. Take care of the loads first. What we're talking about here is it's possible, you hear from some of us designers that we've done this before, and we have done it. The issue is, in this context, prescriptive and the relatively easy path. Well, one angle on that is, and a valid one, is affordable housing. We've talked about that. I'm bringing up that middle ground of mid to large commercial projects, and I think you got the right path here. Yes, by adding heat recovery to my packaged heat pump unit, I can further reduce the load and therefore get it a lot more possible that the unit will be able to produce the amount of heating required, at least down to say 20 degrees, which is what we're talking about in another context. That's all possible, but we're pulling out a lot of stops to do it, which again, I hear is a feature, not a bug.
So Elizabeth, and anyone else really, on the affordable housing projects, I know their ventilation systems are often unbalanced, and which makes ERV a challenge. But would an option where ERV instead of cold climate, is that something that would be doable?
It's actually already required by the 2021 codes.
That's right. I don't think there are exceptions for ERV from what
it's prescriptive. It's a prescriptive requirement. So conceivably you could model around it, but assume, if they're going, we're talking C406 right here. Yeah, if we're doing C406, that PTAC project already has to do energy recovery.
That's right. And many mid-sized commercial don't. Because the way that it below 8,000 hours a year works is it's actually a significant, 50% outside air. So.
And that does it has a great impact in reducing that ventilation loads. It's a strategy we're using right now, and it's a really good one. So I haven't gotten my affordable projects to use it yet, but the ERV plus the package terminal heat pump is it would meet Denver code today, and then some.
Can I ask just one follow-up on that? I like the direction you all are going. I think the reason we put this in here is because we wanted to make sure that we're not saddling affordable housing with high energy bills. When we look at the study that CHAFA has done and others have done, when we're running electric resistance back up below 40 degrees, the energy bills are a lot higher than gas. But maybe that's what's already going in today. And that's if you're telling me that we're at least not making the situation any worse, maybe it's okay. But
no, it's honestly, for the resident impact, this is a non-issue. The rents that are charged are fixed based on your income. It is what it is, and the rent includes utilities. So the utility costs basically drive what the rents are. So, if you're 80% AMI, your monthly rent plus utilities total might be like $600 a month. So if the utility costs are $100 a month, that means the owner can only charge $500 a month rent. So there's zero impact to residents for any of this. This goes all to the developer, the builders, and the feasibility of affordable housing in general is driven by what the delta of the rent is. So it's a non-issue. It's already of huge concern making sure that utility costs are low. Because if they're too high, the projects don't pencil out financially. Like you can't get a loan because you can't charge enough rent. Does that make sense? It's a kind of
that's
complex
certainly super
world.
regulated.
It's
Certainly
very
super
regulated.
affordable housing. It just may not be true if it's not, if it's naturally occurring or anything like that.
Right. I no, you're correct. I should
For the
say,
long.
yeah, I should say those are for, you know, what I would consider true affordable projects that are, you know, tax credit finance, that kind of thing. But those are the ones where also first cost is a really big question.
Yeah.
But with the energy recovery requirement in there, that has just a terrific impact. You can honestly go electric resistance if you've got energy recovery, and you could meet today's code. Not that we would, but that just is a really good benefit.
Okay.
So
what would you propose, Elizabeth, in terms of points here? Or maybe Sean, you have something in mind where maybe there's efficient all electric that's worth more points, and, you know, less efficient but still heat pump all electric that's worth less points or something. What are you thinking though, Sean?
So there are already point options for going kind of above code heating. So what I'm hearing from this, and the idea that's kind of starting to form, is that the all electric, the space heating partial electrification credit would basically have 3 paths in it: energy recovery, cold climate heat pump, or, you know, very low heating energy buildings with electric resistance. So the passive house type building with electric resistance. So there would be 3 paths. You would never have to do a super heat pump. You could do a regular heat pump, any old heat pump that's on the market that meets code, as long as you have the energy recovery. And then that, I think, you know, that fills the energy recovery holes that are in the Denver code right now. And I always have to look back to see which ones are holes for Denver versus other jurisdictions. So that seems to be a doable path based on what people have said. What do our stakeholders think about that?
I see the, you know, technology is going to keep advancing, right? So I think it's a great idea to, you know, incentivize some of these higher efficiency heat pumps. And I don't mean the rated efficiencies, but I mean, I guess the low temperature capabilities. You know, maybe you've got a 406.12A, or maybe that becomes 13, where you've got all electric space heating that meets these standards, and you get some extra points for that. If nothing else, even if it doesn't get used very often, people are going to read the credit, and there's going to be some growing awareness there, because I do think that equipment's coming. It's just not here enough yet, so it may never get used, but to have it out there and to have people start looking at, and then for them, you know, to ask their contractors for it, you know, hey, I want a price for a heat pump that gets me this. What's that gonna get? So you get some of that awareness, you get some of that market interest. If nothing else, there's some positive benefits there.
Thanks, Elizabeth.
And I guess I like what's the direction we're going here. You implied that maybe the non all electric, the partial electric, whatever, however you put that.
Electric space heating, we'll just call it that.
Yes, well, I would suggest that those 3 components maybe are independent credits. So in other words, heat recovery, in addition to, because this is supposed to be the additional heat recovery that wasn't otherwise required, you know, that's its own line item that you can get credit for. This space, you know, all electric space heating is fine. It's just that it's limited in the types of equipment that's available. By the way, I don't necessarily like these, and I don't want to promote it, but VRF should be able to meet that. The issue is whether you believe the rating points or not, because they're not necessarily rated the same way of, you know, COP. You can beat COP at 5 degrees out of the manufacturers, but it's hard. So there are options in using all electric space heating as written. It's just not across the board is my only what I'm trying to put forward here. So if we can add say, heat recovery to that
Yeah.
otherwise standard packaged rooftop unit as a separate line item. That'd be a wonderful thing.
Okay, that's helpful. I think I hear the direction we're going. I realized I think there's three people that joined us after we did introductions, and I meant to circle back and just have them say hello. And then I'll see if anybody has final comments on space heat. We'll turn to water heat because I think you didn't get a chance to run through that, Sean. And I want to check with the group directionally on some of that. And let me know if there's other things. I'll turn to you to introduce that, Sean, and to introduce anything else you still need feedback on, you think, from the group. But Antonio, do you want to say hi? Just run through who I see that missed intros. I know he's often doing inspections, and so it may be hard for him to pop in. Carol, do you want to say hi? All right, maybe she's busy with something else. It's good to see you, Carol. I'm really glad that you were able to join us, even though you were a little bit late. And Johnny, do you want to say hi? Jonathan Rogers.
Hey everyone, Johnny Rogers, Renewable Energy Specialist in the Climate Office. Just appreciate listening in and all the inputs on helping us get our code to a better place. So thanks all.
Indeed. Okay. Any final comments on where we're going with electric space heat? And maybe I'm just looking through our list of general questions before we turn to water heat. Do folks like where we're going with renewables with a cap around at 5%? So that enough other work like electrification and efficiency needs to be done in the building. We'll take silence as a yes, but I'll pause a little longer. Then we'll move to water heat.
So I'll just ask
Would you
one
bring that
question.
one up? Yeah.
So I'll ask one question, and I may be missing it, because it sounds like we combined R406 and the renewable energy proposal, on-site renewable together. How does this affect the performance paths? Does that mean on-site renewable needs to be added to the performance paths, or what happened to the performance paths in this on-site renewable?
Yeah, go ahead, John.
So right now, all that has happened really is that on-site renewable got absorbed into C406. The credits weren't increased. I think we heard pretty clearly that just pushing on renewables, pushing on electrification, pushing on efficiency all at the same time was really challenging for the stakeholders. And so recognizing the issues with mandatory renewables, we're really focusing in on electrification and efficiency. So for the modeling path, we do have the same issue of just making sure that the prescriptive and the modeling path stay calibrated to each other. Wherever the points land, wherever the credit target lands for prescriptive, that the modeling path is requiring the same levels of efficiency. And within the modeling path, there is already this, you can use renewables to get to a certain amount of it. But there is a cap right now in the modeling section as well. So those things would stay the same. We would want parity on both the value of electrification and the value of renewables, and what we're asking in terms of efficiency between prescriptive and modeling.
And I think the renewables in both current drafts are capped at 5%. So that we drive enough efficiency and enough electrification, not because someone might not do a larger renewable system than that, but you only get 5% credit. I think in both current proposals that separate working groups are working on. Yeah. Great. Okay, let's turn to water heat, unless there's some directional comments. We hadn't heard from you all on that general direction. So wanted to do a check. But I think that's what we're consistent with what we said last time. So on to water heat.
All right. So a similar idea that the electrification of water heating would need to be accompanied by a certain amount of efficiency. So in this case, it would need to be provided by heat pump water heaters. And in this case, it's fairly straightforward. We're not talking about cold climate because we don't have any kind of rating for cold climate heat pump water heaters like we do for space heaters that we can leverage. And we have a couple of key exceptions, and these are brought over from the electrification proposal that we were discussing. That these small pony water heaters, the low boy or instantaneous water heaters are exempted from this because heat pumps really aren't necessarily appropriate for that. High temperature heat water delivery, because the market is, we're beginning to see equipment that can do that, but it's not quite market ready yet. And then these other strategic exceptions. So in order to get the water electrification credit, you would need to do heat pump water heaters.
Do folks have comments on this specific language, or we can scroll back up so you can see how many points are proposed? You also have this draft. Courtney sent it on Friday.
So I think there's a philosophical question here. Does Denver prefer gas water heaters or electric resistance water heaters? Would Denver rather have electric resistance water heaters than gas water heaters?
I think because of the operating cost concern, and because it's not much better with our current grid, at least for the climate, that's why this is written around heat pumps, right? I think gas is about the same for the climate and much lower operating cost than electric resistance water heaters. It's my understanding, but I'd love to hear, that fits the group's understanding, and I'd love input. Mark, do you want to comment, or Elizabeth, do you want to add on to that first?
Yeah, I mean, my philosophy right now is once you have a water heater that's attached to gas, it's going to be like that forever. It's very difficult to get it off of gas and to get the electric capacity to the building. So I personally would rather have projects do electric resistance water heaters than gas water heaters. So if we're not having, any kind of nudge, at least in that direction, we're not going to get building electrification successful. I mean, we've had this conversation. I am trying my damnedest to get these heat pump water heaters into multifamily projects, and it is just hard. But I can get electric resistance water heaters in there, and that's when I can start to get electrification to pencil out. So if we really want all electric buildings, I think you've got to consider the electric resistance water heaters as an option, as an all electric building.
Okay, I'd love to hear from others on that. Mark, do you want to go ahead, and then Johnny?
Yeah. I think, first of all, I hear where Elizabeth's going here. I think that this has covered, in other words, because this is a credit, this isn't required to meet a all electric building. Now, I also support Elizabeth in saying we got to know what an all electric building is before we can make judgments like that. But I'm guessing that a building that has a resistance water heater meets the code minimum for an all electric building if other things are covered. So this would be
that's a great point,
that,
Mark.
Right?
That's a great point, Mark. I might have misinterpreted that, thinking that this was the requirement to fit into that all electric category. Right. So I could have just gone completely down the wrong path. So my apologies if I did.
Yeah, prescriptive could have been just really all quick. Electric water heaters. I'm going to spend a little bit more and get a credit. That's the way I read this. And
Sean, do you want to clarify?
Yeah, I did want to clarify. So if you look at the table, to be able to use the 10 credit column, you have to have an all electric building, which is defined. And then the all electric building has to have what is essentially this better electric space and water heating. And that's one of the things that is one of our discussion topics today, whether we should have it that way. But right now so this would apply both to all electric buildings and to partial electric buildings that want this credit.
Yeah.
And we can discuss both aspects of that.
Right.
So once we set that as the base, that's a good explanation. Thank you. Now here's my real question, and that is, does this really do us any good? What do we think we're buying here? Usually, probably what we think of when we say a heat pump water heater is the tank type water heater, 50-gallon, 40-gallon type water heater. That looks pretty much just like every other water heater. It's just that the top part of it is a heat pump. It has grills on it, and that's a heat pump water heater. That's probably what most of us think of. where does that get its heat from? It gets its heat from the building. So if you've got a gas-fired building, you've got a gas-fired heat pump because it's just sucking the heat out of the building to put it into the water. If you've got an electric resistance heated building, you've got an electric resistance heated water heater because it's just sucking heat out of the building in order to get the heat into the water. Further, most of these, again, what you get out of the color brochure, just the standard state, A.O. Smith, Rude, Ream, all those standard units, is when you look at the ratings and you say, yeah, look, it has the same rating as my a normal 40 or 50 gallon water heater. That's at the hybrid rating. Let's say a unit that has, just to pick a number, 100 MVH of heating, probably only has about 30 MVH of heat pump heating. And in heat pump mode, it'd take a very long time to recover that 40 gallons of water. So when they express the heat pump, the heat recovery rate of the water heater, it's always at the hybrid mode, meaning that resistance heat actually did most of the work. So it's cool. I will apply this. I will use it as a credit. It's just I'm asking, what do we think we're really getting out of it?
Thanks,
as far
Mark.
as efficiency?
Let's just make sure we hear from others because we're running out of time. That's helpful. Johnny, and then Chuck. I want to make sure yeah, go ahead. You're muted.
Yeah, but I think there was some good clarity on what this rule and exceptions really relate to, but I just wanted to second what Elizabeth was saying, that I think it is, very important that we put in the electrification measures, even if it is electric resistance early on. Going to be very hard to electrify gas buildings later down the road once that infrastructure is already in place. Given the trajectory we're seeing of the grid, I think that carbon benefit is going to quickly turn in the favor of electrification, even with resistance heating. And that would hopefully also help with the technology improvements of these heat pump water heaters, just getting better and better over time, if that's what we're building them for.
Thanks. Chuck?
Yeah, and I would agree with Elizabeth and Johnny on that. I'd say electric water heaters, resistance or heat pump is a good way to go. If we're going to allow electric resistance, maybe have some guidelines like the proposal where the space that water heater is located in is suitable for a heat pump water heater in the future, to help prevent another hurdle down the road from converting to a heat pump. And then my question is sort of, how do these exceptions apply to this? Because it's kind of going for a credit, but like the 20-gallon water heater, like a retail strip mall with just single restrooms in each tenant or double restrooms in each tenant, can easily have just these small electric resistance water heaters. Would they qualify for this? Because I just don't understand how the exceptions apply.
That's a good one. Yep.
Yeah, Sean, do you want to clarify that and then kind of what you're thinking about what you might propose back if we want to at least have some points for electric resistance? Sorry, go ahead, Chuck. Finish what you're doing.
And even more extreme, like a high-rise building could easily have a 20-gallon electric water heater at every floor serving the restroom group because it's just labs, and then have individual water heaters at the break sinks and get around this. Would they qualify for this credit then? Although because they meet the exceptions, or I don't know.
So maybe the language it'd be good to clarify a little bit on that one, that it's electric. But I think the way that the credit is structured, most of the value of the credit comes from the electrification. And so in those cases where you have such small service water heating loads that you can do it with small electric resistance tanks, it is envisioned that, yeah, you would be able to get the credit for doing that. That it's only when the water heating loads get larger and therefore the costs get more of an issue that it would require the higher efficiency water heating. But if the group, we've heard a couple of very strong, I don't want to say strong opinions because that almost sounds derogatory, but clearly expressed opinions that electrification is more important than the efficiency on this, then if that's the direction that the working group thinks we go, then this gets rewritten substantially to align with that. And then I think probably the big question comes, do we have some kind of ameliorating condition for electric resistance, or at least larger electric resistance loads like we did in space heating? You know, like if it's electric resistance, does that make energy recovery mandatory or something like that? I know that energy recovery can be challenging in hot water systems. So do we need something like that, or is the value of electrification so high that really we just go straight electrification of water heating?
I would promote if heat recovery is just another point. Don't necessarily combine them, but just give me that flexibility to combine them myself.
And maybe heat pumps get slightly more points than just electric resistance.
That's what I was going to suggest.
Well,
right?
Yeah.
So there would just be, it complicates it a bit more, but there would be points that you get this much just for being electric, you get more if it's a heat pump. And if it's electric resistance, it has to, do folks like Sean's idea that it has to be something that can be converted to a heat pump? It has to meet certain, or Chuck's idea, it has to meet certain conditions so that it could be converted to a heat pump in the future.
We already have that language written for the electrification readiness proposal, but that proposal always could fail.
What Elizabeth pointed out is if you've already got enough in there for resistance, whether it's heat or water heat, or you've got enough for resistance for a heat pump, that
Right.
almost I can't imagine a case where if you put enough in for resistance, you won't have enough for heat pump.
It's more
Right,
about the space at that point.
Right. It's about space and about cold air venting at that point. And ideally, to
Well-
your question, Mark, like, are we really doing anything? If we vent the cold air to the right spaces, then yes, we can be, right? But it depends on how it's set up.
It's a big, it depends. Exactly. And that's why, but that kind of, it may not matter if the only goal here is electrification. Because you know what, cooling the air when cooling's needed is a benefit, but cooling the air when it's not isn't. And this is supposed to be the prescriptive easy path. Yeah, sure, make me model it if I want to take credit and everything for that. But otherwise, I don't really have an issue. I just want us to make sure that we're getting what we think we're getting. As another point on that, I'd like you to take a look at the base code has a credit for heat pump heat recovery. What is that? I just was there. C406 7.4, and it requires, in order to get that point, which is 7.4, which is only, doesn't even apply for B and M, right? In order to get that point, it's got to not suck conditioned air. So the base code recognizes that in order for it to be a benefit, it's got to not draw conditioned air from within the building, except where otherwise exhausted the exterior, which again, good design, but that is what makes a water heater, a heat pump water heater, more efficient than any other system, is if you take the heat out of something that was otherwise being exhausted.
Right. And you should get more points if you've done that.
You would get it. So if that's the intent, you could get your C406.13 points and your C406.7.4 points. If that's okay, you don't need all that many points in an all electric building, but that's the calibration part. And that's the part that's a little bit difficult to do on the fly. I understand that. And I'm just pointing out, how would you want me to design?
Okay. One more minute left. Sean, any final question? I think you got a lot of good direction. I think we'll be very close in the next meeting. We'll see if we get there or if we need the fourth one.
I think just so that we are painfully clear, it doesn't sound like the working group really favors anything to be added to water heating and electrification other than electrification and maybe some, heat pump water heater space requirements so that you can get a heat pump water heater into that space in the future, but nothing like heat recovery or anything else. Are we hearing that right? Or I should say, am I hearing that right?
I'm
Wait, hold on, Mark. Elizabeth,
Yep.
can you?
Oh, sorry. I was just gonna say, I'm not sure I totally understood what the consensus was, but it sounds like maybe there was interest in giving a tiny bit of incentive to electric resistance water heating and then extra incentive to the heat pump water heating with the considerations that Mark brought up. So maybe that's split a little or something.
So maybe the all electric water heating measure stays as electric resistance, but the points just go down a little bit so that electric resistance doesn't get you quite as far. You would need to go to higher performance to get some real points.
Yeah, but I still like the idea of having some incentive to nudge people in that direction. That gets the building off of, well, less gas, right? That's a benefit.
Right. Makes it easier to convert to heat pumps in the future.
Right.
Okay. Thank you all so much. We'll let you go. Thank you so much for your time in these working groups to think through this stuff with us. Happy to stay if folks have things they want to add. I just want to be respectful. It's 4:01. Thank you all.
Thank you.
Thank you.
Anyone adding anything? All right. I think we're good.
All right.